Hello, everyone. Welcome. Thanks for joining our diagnostic training session today. And what you're about to see is a pre-recorded training session we did over in the United States. But be assured that a lot of the material that we cover is really applicable to any automotive application. So just be aware that yes, it is a lot of North American vehicles, but they will apply a lot of the same principles apply over in the UK as well. Now, if you do have any questions, if you're watching this during the premiere, you can just leave it in the chat. We'll be monitoring live chat. If you're watching this after the premiere, then just feel free to leave a comment underneath the video and we'll get to those as we can as well. So my name is Jason Gabrenas. I'm one of Snap-on's diagnostic technical trainers. I've been in the training department since 2013, traveling around North America, helping techs and shop owners get the most out of their diagnostic equipment. Before I did that, it was a couple years as a diagnostic sales rep at Snap-on, so I had 30 different franchisees I worked with, as well as the shops that they serviced, in order to help everyone get the most out of their diagnostic needs. Then before I did that, it was 8 years at Subaru, so I worked in a dealership, and over time, I guess, just became the default diag guy in the shop. So I always ended up having the drivability problems, the intermittent problems, the weird wiring problems that would show up on those cars. And that's really where I cut my diagnostic teeth, was trying to figure out all those weird head scratcher type cars that would come into my bed. Then before that, a bunch of other miscellaneous wrenching jobs. Been a little over 25 years under hood experience for me. Our topic today is code basics. We're taking it back to the basics, but some of these classes, these next line of classes that we have, some of these actually came from our tech support. And they say, some folks call in and they're not entirely sure. Some weird things go on with codes there. It's not always straightforward. It's not always cut and dry. So we figured, well, let's put some classes together to talk about, different things such as code basics. If you've been in the industry long enough, way back, 80s, 90s, or at least 80s, 90s vehicles, the first diagnostic tool for technicians was that paper clip there, right? You'd unfold it, you plug it in, and you count how many times that engine light would flash. Hopefully you counted it correctly, so you weren't misdiagnosing or diagnosing the wrong code, but you would watch it flash and you would get the code that way. Up until OBD-II, some vehicles were that way. Even after OBD-II, I know to get certain codes out of a Subaru, for example, even in the 2000s, you would need to do a flash code with that. So let's take a look back to that early day of the later of the early days. This is 1994, so OBD-II didn't come till 96. This is a 94 Honda Civic, and back then there were 23 possible codes in the ECM that you could get. 23, that's it. Made it a lot easier to diagnose because it was only a few possible things that could throw a code. Whereas if we go to a 2022 Honda Civic with a 1.5 liter engine, there are 23 different systems that have codes. And then if we scroll through, as you can see, this is just the engine system. You can see how many codes are in there. 300s, 400s, 500s. And all of the different code numbers have a different meaning. We'll talk more about that in a little bit. But you can see, as we're scrolling through this is just a 2022 Honda Civic. It's nothing special about it, but there is a lot of codes now. And this is just what we deal with nowadays, this information overload. So many codes. But also back then, we had all these different adapters that you would need, right? So any of our Snap-on scan tools, any of the tools we have would work with these adapters, because we do go back to 1981, even on, brand new Zeus Plus can read these cars all the way back to 1981. You just need a special adapter here that adapts to any of these different adapters. These are OBD-I adapters. These are the European ones, and these over here are the domestic and Asian ones. So back then, pre-96, pre-OBD-II, it was really the Wild West out there. As the manufacturers could have any sort of pin configuration they wanted, and there really was no rhyme or reason to it, which is why OBD-II really helped us, at least in that aspect. I don't know if it helped anywhere else, but it definitely helped in that aspect of having a standardized connector, standardized protocols, standardized codes that they would use, and it would be the same from manufacturer to manufacturer by and large. Also, in this transition time, though, the mid 90s era, mid to late 90s, I guess you could say, we did run into some interesting half and half say cars, right? So we have a Mitsubishi or DSM back when they were affiliated with Dodge, and so it was Dodge, Chrysler, Eagle, like an Eagle Talon and a Mitsubishi Eclipse for the same thing, that sort of thing. So back then they kind of had it half and half. So you'll notice on this screen here for this 97 Eclipse, connect the OBD-II adapter with the K7A key and the Mitsu 1 adapter. So if I back up one slide, the Mitsu 1 adapter was this thing right here. So this end would plug into here on the adapter cable, and then this would plug into the manufacturer's port. And then you would also hook up an OBD-II connector, which isn't shown here, but you would hook up the OBD-II connector with that key and plug that in the OBD-II port. They were kind of like right next to each other. And you would have to plug both of those in order to communicate with the vehicle. So the tool would prompt you, right? So it said, take that in the Mitsu 1 adapter. Under the driver's side dash, do not connect a 12-pin connector. So you would see you needed a special, that was one of the weirdest ones, I think, where you had to actually use OBD-II and the proprietary at the same time. Also, even into the 2000s, here's a 2000 Mercedes E-Class. We need the MB1 adapter with the S20 key. So that is this right here. So we have 32 pins, I believe that was. Multiple pins, way more pins than we have pins on the cable. So we needed to use a key to split them down. But that was their proprietary connector under the hood for the longest time. And then BMW had the same deal too with their 22-pin connector, which we'll see right here. So BM1B round connector. And this is on an 01 3 series, right? So some networks it would be on the round connector, some it would be on the OBD-II. So you'd have to read through multiple different ways in order to read the car. So that's even on a 2001. So that's what, 5 years after OBD-II became the standard. They really held on for a little bit longer. Speaking of having differences in different data and so on, so you may have heard me before talk about it at vehicle's computer and talking about it like a house. It's got a front door and it's got a back. But what we don't always talk about is that there are 2 rooms inside this PCM as well. They both take the same raw data. So we have one main input or one main front door, but we have the OEM VIN specific side and we have the EOBD generic side of the PCM. So this is your federally mandated side, data and codes, emissions related mostly in here. And then the OEM side is going to be have all the OEM codes plus any of the OBD-II codes. And the reason we need to look at both sides, because it's going to output data and codes out of these 2 sides, there are different thresholds that may be in here. So this side of the computer, the federally mandated side, that is going to be the same threshold no matter what. So once it hits XYZ, then it's going to set this code. On the manufacturer's side, that threshold could be higher or lower. So as we'll see in a little bit, you may scan a vehicle and it has different number of codes on either side. They also have different codes of descriptions, perhaps, because the manufacturer may have a 1 description versus the federally mandated side will have a one size fits all description that's standardized for everybody. So we need to take that into consideration when we're scanning the vehicle. Now, if we do a full code scan, it does check both sides and it checks both sides for codes, but you may see a discrepancy, and that's why you may see a discrepancy, because there can be different thresholds in there. So it used to be we would have to go into the scanner and then OBD direct. And if you don't have a full vehicle code scan on the vehicle, it's an older vehicle, you would want to do that anyways. You can go into scanner, you can go into OBD direct separate and check the codes. Also, I'll show you another way that we can do that from within the vehicle itself and then switch over to that room as well. But just remember, there are 2 different rooms, so there may be 2 different thresholds, 2 different types of codes that you will run into, and that's just why that happens, because one's for the vehicle manufacturer and one's for federally mandated. We have different code types. We're going to stick to OBD-II really for the rest of this, but there are different code types. We have a current code, which means there is a problem right now. We have a problem right now. Pending code means there's going to be a problem. pretty soon. It's pending, but it hasn't. Maybe it's a 2-trip code or something like that, where it takes a couple drive cycles to set. So it's impending. It's sitting there. We're looking to see if there's going to be a problem. History code means there was a problem, but it's probably okay now. You might still want to check it for reference, but oftentimes your history codes would be things like battery voltages, stuff like that, where the battery voltage dropped it low overnight, and then when you started it up, it was fine. And then there's permanent codes. Permanent codes, there's a little bit of confusion on that as well, but it's very helpful for you if you're checking on a car that somebody else has worked on. We'll talk a little bit more about that in a minute. But a permanent code is, well, there was a code, there was a problem, and I'm going to stay here and let you know that until the test passed. So it'll go and that'll be there. You cannot clear it until the computer itself will clear it for you when it runs the test. And then for OBD2, the code designations. So we have P codes, which P stands for powertrain. We have our B codes, which stand for body, C codes, which stands for chassis, and then U codes, which stands for UART, and we'll talk about what that means in a minute. So P codes deal with powertrain issues, and these are going to be our most common codes that we're going to see, engine and transmission by and large. They also have subcategories based on the number. So even if you don't have a description, you can kind of figure out roughly what part of the vehicle it's looking at when it comes to the codes. So P00, 01, 02 is fuel and air metering. P03 is going to be ignition system or misfires. So P0300 is the random misfire that we see all the time, 301, 302, 308. Also, the 300 series, that's your cam sensors, crank sensors too, because that's dealing with your ignition system. P04, auxiliary emissions controls like EVAP. P05, vehicle speed and idle control. P06 is going to be your computer and your auxiliary inputs there. P07, 8, and 9 going to be transmission control codes. And then when we get into the A's, B's, C's, that's usually reserved for hybrid vehicles, electric vehicles, or just other systems that don't really fall into these other categories here. So if you ever see a POA01 or whatever, just know that it's probably dealing with either hybrid or electric or something else that doesn't fall into this category. So these are the OBD2 code descriptions, right, from the standard, the OBD2 standard. The manufacturers can also have specific categories as well, and they go through the same basic format, except in this case, we start with a leading 2 or a leading 3, depending on the manufacturer. But fuel, air, and auxiliary emissions, ignition systems, aux emissions controls, auxiliary inputs, computer and auxiliary inputs, transmission controls, the 789, just like before. A's and B's are in powertrain control, and then we get a 3000 code, which I was able to find for cylinder deactivation there. So there are thousands of possible codes that are out there now. High, low, short to ground, short to power, outside of range, not performing correctly, whatever the manufacturer decides it needs to be. But there are codes for so many different things now. We just need to be able to go through, read the definition, figure out what's going on. And this at least helps us a little bit to figure out roughly what area we're looking at. Then we get to our B codes, our body codes. So that can apply to multiple systems or ECUs, such as, well, the body control module for sure, HVAC, supplemental restraints, audio and entertainment, ADAS, of course, big one there, seats, doors, windows, those sorts of things that are body related. Then we have our chassis codes or C codes. So that applies to, once again, multiple systems and ECUs, ABS system for sure, traction control, vehicle dynamic systems, suspension, air suspension, or electronic suspension. Those would all have C codes to help you with the failures. And then we have our U codes, the UART. So UART stands for Universal Asynchronous Receiver Transmitter. So it is a general communications protocol used in hardware, so ECUs. So that'll apply to most systems on the vehicle. If there is a network issue somewhere on the vehicle, which those can be a little more challenging than some other things to solve. But when you're doing that, it's going to help you identify communications issues on the network. So the one thing I will have to say about a U code is can be descriptive, but can be challenging based on the description to narrow down where the problem actually is. If a lot of the modules are pulling the same code and pointing at one other module, then it's going to be more helpful. But U codes, by and large, at least in my experience, aren't always the most helpful thing to diagnose a network. Usually it's just look at it with a scope and see what's going on. And then we also have detail codes, or also commonly known as subcodes. They provide more detail to the code, which will help the technician know whether it's short, open, or other details in there. So if we come over here, we see this list. This is out of 2021 F250. All right, so we have a B11D9 subcode 16, which means vehicle battery circuit voltage below threshold. But if we have that subcode 17, you see how it's the same base code. So 16 and 17. So 17, vehicle circuit voltage above threshold. We can go down here, same type of thing. So CO6A1. 11 is hub disconnect motor A short to ground. And then we have short to battery, open circuit, etc. So the more detail we can get. So the C06A1 means it deals with the wheel hub disconnect motor A control. And that's what that deals with. And then our subcode or detail code tells us short to ground, short to power, etc. So it's just a little more expansion over the base information that we usually get. So that is P codes, B codes, C codes, U codes, the standard OBD2 codes. There are other codes that we could get time to time depending on what type of vehicle we're working on. We have hex codes that are out there and decimal codes. So they use a hexadecimal format, which honestly all the P codes and B codes and whatnot do as well. So 0 to 9 and A through F are what's going to traditionally be used in these codes. So you're not going to see anything more than F, because F is 16. So 0 through 9, and then A through F gets us 16 bits. So that's hexadecimal. For example, on a BMW, you might find a 29 CD or a 0x29 CD, which that would be a hexadecimal type code. We also have these decimal type codes here. This would be more of an OEM code on a Volkswagen. So that's on a 17 Jetta. You see we have a P code, and then we also have the other manufacturer specific code dealing with whatever different system. In this case, we have injectors, right? Let's talk about a couple of the other differences that we might see out there that might catch you off guard. So this was on a 2011 Chevy Silverado, and you see it's got a 128 code, which is an engine coolant temperature sensor, PL13E, which is oxygen sensor delayed response, and then PL513 theft deterrent key. So it's got 3 codes in the engine, but if we go down, remember how it scans the OBD2 side, on this vehicle, it did not have any codes in OBD2. So you may experience that at some point, that the thresholds may be a little bit lower on the manufacturer's side than it is on even the OBD2 side. So that was just kind of an interesting one that I found one day. So it's has a couple of those different codes, and it's just no OBD2 codes. You still have to go and fix them because it's obviously still a problem, but it's not enough for the OBD2 to light up. Honda codes and also a couple other Asian vehicles seem to like doing this. So they'll have permanent codes and temporary codes, or current codes and history codes. You might see them laid out like that as well. So you'll have different labelings, different headers for that. Also with this, we have P0011, which is a fairly common code, right, for VTC system malfunction. But if I go down here to the bottom, you'll see that the P0011, according to OBD2, is a camshaft position timing over advancer system performance thing. So you could have different code definitions with the same code back and forth. So just be aware of that you could see different definitions, and that's okay. That's normal. Just the manufacturers decided to change it up a little bit. BMW, that gives me that example of that hex code, right? So we got a 29 CD, which is a misfire on cylinder 1, or a 2E81, which is water pump. This is just on a 2013 3 Series vehicle. You'll find these pretty commonly on BMWs. Mercedes has a different format. Volkswagen has a different format. So you will see some different formats out there that aren't necessarily P codes, B codes, C codes, but it is out there. And then we get to permanent codes. So permanent codes, I think one of the biggest calls we get dealing with permanent codes is, hey, I have this car and I cleared all the codes, or at least I thought I cleared all the codes, and I still have this code here that I can't clear. And it says OBD-II permanent codes. You cannot clear these using a scan tool. This is part of OBD that is very useful for you as a technician trying to diagnose somebody else's problem that they may have seen. So if it hasn't passed the test yet, but it still hasn't set in the actual computer, the permanent code will still be there as a record of, hey, this was here. We haven't run the test yet, or we haven't passed the test yet. So that can be useful if you say, oh yeah, I had a problem and so worked on it, but then they cleared everything. Well, this won't be cleared no matter what. So those are impossible to clear with a scan tool. You just have to wait yet to give it time. All right, so let's look at a few more examples that we can talk about. Some places where you might get a little tripped up, so to say. So let's look on the tool here. First one I want to talk about is got a 19 Chevy Silverado. This is it's really just to discuss GM in general, the way they do their codes, because there's one thing that might trip you up in here. So it's really in a lot of the modules. But if I go into engine and I go into my codes menu and you see display codes. So we have DTC display. We have not run or failed since code cleared. And then we have not run or failed this ignition cycle. So we have had people say, hey, I go in here and I click on that and there's like 100 codes in there. What's wrong with this car? Well, you have to make sure you read that. It says not run or failed since the code cleared. So if I cleared the code and I immediately went in here without doing anything, without restarting the vehicle or anything, all the possible codes are going to be in there because they haven't run the test or they haven't failed. So if we go back here there's a codes help button. On this codes help button, it's going to tell you what is going on in that other section. So DTC display is going to be a list of all current and history failures. When you clear codes, there should be no codes in this list section. Right? Makes sense. So I'm going to clear it. When it's clear, it should be clear. Not run or failed since code cleared. Codes in this list have either not run their test or their test ran and failed since codes were cleared. If it ran and failed, the code would also be in the DTC display section. When you clear codes, there will be many codes on this list until the test for each code runs and passes. Not run or failed this ignition cycle. Codes in this list have either not run their test or their test ran and failed this ignition power-up cycle. If it ran and failed, the code would also be in the DTC display section. So just so you know, if you pop in here and just randomly I don't know, maybe just don't read the button or what have you, you can go in there and there'll be a ton of codes and you may think, oh, what's going on? Something wrong with the scan tool, something wrong with the car, none of those things. It's just that's how GM does it. Also, I told you that I would show you another trick to do to go onto the other side of the computer, right? Because right now we're in the vehicle specific, we're in the scanner function. So that would be the VIN specific side, the OEM side. If I wanted to flip over to the OBD-II generic side, over here it says generic functions, and this shows up on many vehicles, not all vehicles, but many vehicles. We can pop into generic functions, and then you can go in and get most of your OBD-II generic stuff, like your readiness monitors, freeze frame, clear data, calibrations, etc. are available in there. Plus your mode 6 is available right from between generic and the VIN specific. Okay, so that's that. Let's go into have another one that might trip you up here. We'll do this F-150. And in this case, we will go into Schottky. So really, in any case, working with codes, repair information is going to be your friend. Here's one that trips up a lot of people on Ford. So I'm going to go and clear codes on Ford, much like on that Chevy. So if I cleared codes on this Ford, and I don't really do anything, I'm going to come back with a P1000. People think, oh, well, I still got a code in this vehicle. What's wrong? So the P1000, if I go in here, P1000 description is onboard diagnostic system readiness test not complete. So just by that description, you can understand that we haven't completed a drive cycle. The OBD monitors are carried out during the OBD drive cycle. The DTC is stored in continuous memory if any of the OBD-II monitors do not carry out their full diagnostic check. This DTC is not supported on all vehicles. Refer to OBD drive cycle for additional information. So most commonly, like I said, found on Fords. Possible causes: the vehicle is brand new. PCM DTCs have recently been cleared with a scan tool, so I cleared them and I haven't run my tests yet. PTO circuit concern, or the PTO is on. An OBD monitor concern occurred before the completion of an OBD drive cycle, and battery or powertrain control module is connected, so people disconnect the battery to clear the code sometimes, and then that just will set that P1000 code. That means basically the same thing as that giant list of codes on the GM is going to be that P1000. This DTC IM readiness function is part of the PCM strategy. A battery disconnection or clearing codes using a scan tool results in the various IM readiness bits being set to a not ready condition. So there's a lot of other stuff there, but P1000 does not need to be cleared except to pass a test. Mill flashes after a period of time and the ignition is on position if the P1000 is set. So you might see that as well. So all it is telling you that it hasn't completed a full drive cycle, hasn't completed all the tests. So if you ever come up with a P1000 on a Ford, that's why. Let's go look at Mercedes. We'll call it that. So if I want to pull in the codes, the full list of codes, I have a DTC index here. So let's go into the engine, and we have engine control DTCs. So you see Mercedes-Benz DTC versus generic DTCs are going to be. Let me see if I can find. No, not on this one. So on some of them, they will have a much larger digits that they will list. So these are Mercedes-Benz codes versus generic. Okay, so let's change to a different vehicle. Let's do like that 13 BMW. Okay. So in this case, if I wanted to look up 29 CD, oops, CD. Oh, that's that cylinder misfire, right? 29 CD engine, and then we go into OEM testing. It is going to give us multiple different things. So we have a BMW HEX code of 29 CD. Remember 0x29 CD, we talked about that. Or the DES, which is their decimal, 10701. Or it's really a PO301, but it doesn't translate, right? So we have different criterias and so on. It's also really a good idea to check the code set criteria, see how many times it has to run, 6 crank rotations after start before it figures that out, coolant temperature greater than 6.8 degrees Celsius. So this can help you in order to diagnose the problem by duplicating the conditions. So monitoring criteria, combustion consistency measurement, starting engine speed greater than 450 and less than 7,000. Ambient pressure greater than 740 HPA. So being able to go in and read the descriptions will help you out with diagnosing these codes as well. I mean, of course, we're going to have flow charts and such. And then we can use any of our other techniques that we know, anything else that we may have learned throughout our experience and so on in order to help us diagnose these problems. So hopefully we got a few little nuggets that you can take away from these code basics and maybe apply it to something going on a little bit down the road in the shop. Maybe you can apply it tomorrow in the shop. Maybe you learned something you hadn't known before. So